we're going to get started. I'm going to talk for a second, another minute, see if anybody else comes in later. So we're finishing up the formulas, the identities that we're covering with today. So we have a whole new slew of identities that we're covering today, and we'll be using them. And then after this, I had on the calendar that we were going to cover vectors, but I'm going to switch that. All right. So instead, we're going to cover polar graphing and polar equations tomorrow. Okay. And vectors will be Monday of next week. So if you have your calendar, then you can just switch them. And then we'll still finish up with law of sines and cosines on Thursday. Understand, according to the calendar, we have another test over this new material, identities, equations, law of sines and cosines, polar and vectors, that will be covered a week from today. So a week from today, we have another test, all right, on the calendar. And then after that, we're done with trig. We go back into college algebra type stuff, okay? So we're gonna work with our double half angle formulas. Sum and difference we did yesterday. So sum and difference we kind of handle all on their own. And now that you have a somewhat of a feel of what we're doing, right, where you're kind of just using these identities to find exact function values, as well as maybe being able to replace something in an equation so that you can solve it or whatever. So we're going to add to that list by talking about double, power reducing, and half angle formulas today. Okay, now when you take your test next Tuesday, right? What did I say? A week from today, which is Tuesday, right? So when you take your test next Tuesday, I will allow you to have a formula card for these formulas that we've been dealing with. Okay, that'll be nice, right? Because there's a bunch of them. Right? But you need to be working on memorizing these. I know that when you get to Cal 2, the professor in Cal 2 is going to really want you to be able to recognize these identities, like the double angle identity right here, where you're going to substitute in for some sort of integral or derivative. Okay? So that's kind of where you're going with these. You need to be practicing with them. But I'll let you use a formula card for the test that we have coming up. So we're going to start out just talking about our double angles. And you can see in here, we have a double angle for sine. In fact, we could have solved one of our equations the other day that was a double angle. If it fell in this form, we could have probably tried to solve it using a substitution here, if it works that way. But we have a double angle for sine. Notice that it's the angle, right? It's that variable next to the trig word that has the 2 on it in this case. And when we rewrite it, we can rewrite it so that it is a single angle. We're kind of reducing it or combining it, I suppose. You've got your tangent double angle, which is a fraction, right? We don't really like those, but there you go, you got those. Then you've got cosine double angle, and there's 3 variations for the cosine double angle formula. All right, they all can be interchanged. You would just pick the one that would be more appropriate for whatever your use. Okay, double angles. Y'all got those written down? Okay, I'll give you just a second to finish getting those written down. Okay, so the double angle formulas that we have here. We're going to use them here using sine and tangent. I'm going to find the double angle of sine and the double angle of tangent. So if I know that sine is equal to, if I know sine theta is equal to -4/5, I know theta is in quadrant 4, right? I've got those two components to be able to use to break down what I need when I'm finding the identity. So we have identified, we've said, according to our formula up there, that sine 2 theta is the same thing as 2 sine theta cosine theta. So I'm going to use what was given to figure out what cosine theta is, to then plug it into the identity, similar to what we were doing it the other day.
So we just basically got to find, so basically let's put like a sine in a triangle and find the missing angle and then find the cosine.
Yes, all right. So we know that sine theta is -4/5. We know that sine is defined as y over r, right? Y over r, or opposite over hypotenuse, okay? So if y is equal to 4, r is equal to 5, then x has to be equal to what?
3.
Very good. We're in the 4th quadrant, so y is negative in the 4th quadrant, isn't it?
Yes, ma'am.
Okay, so we have all of those components up there. We can come down here and we can say, okay, so 2 times the sine of theta, and let me back up as we're going along here. We know sine theta is equal to -4/5. We know cosine theta then has to be equal to +3/5 there. It'll be easier to see. So when I substitute in here, I've got 2 times -4/5 times +3/5. You don't see that?
-3/5.
All right, and when we multiply across, we're gonna have 2 times 12, which would be 24/5, -24, I don't know what I said, but -24/25. Not so bad, right? Just applying the identity. We know how to find sine and cosine, given the information at the top, right? So if we look at our tangent theta, tan theta, we defined as 2 tan theta divided by 1 minus tan squared theta. So tan 2 theta, our double angle, identity says that's equivalent to 2 tan theta 1 minus tan squared. So we want to add to our information that we're, writing up here. If I am still talking about this angle theta, then tan theta has to be equal to -4/3, right? And tangent is negative in the 4th quadrant, so I got the sign right there.
So 2 times
And now it's just us plugging into this expression. So 2 times -4/3.
they want to be 1 minus 4/3 squared.
Yes, it would. Divided by 1 minus -4/3 squared.
Maybe
So on your calculators, y'all push a bunch of buttons. Let me know what you get in fractional form.
-4/7.
Okay, I got 24/7. Javi got 24/7. You all make sure you can get 24/7 in your calculator. Just making sure.
That's part easy.
Calculator skills, right? That's all that part is. Any questions on applying those identities? We didn't do cosine, but we'll have plenty of time to practice that, but it's the same concept, right? The double angle identity for cosine, you pick one of those, plug it in, boom, you're done, okay?
Also, any of the 3 formulas listed for cosine would work?
Yes. In fact, if I asked you to find the double angle for cosine, any of those would work. I would probably say that I might use this one right here, because that's the only identity that I'm using the actual given in the problem, right? In the other two forms of it, I'm using some information that I calculated on my own based on what was given. So I might choose the one where I didn't mess anything up already, right, before I go and put it in the identity, if I have the choice. So that would probably be how I would address that. Okay, questions on that? Just make sure you can get it in your calculators. If you can't, we can always talk about that later. All right, let's look at this one right here. It says the tangent of, it says 2 times the tangent of 2 tan 15 divided by 1 minus tan squared 15. Practiced this yesterday, right? What does this look like? This is in the same form as our double angle identity for tangent. And the angle that we are looking at is this angle here of 15, should be 15 degrees. And so we say, okay, well then that looks like the tangent of 2 times the angle 15, because that's the angle, that's the identity. Or in other words, the tangent of 30. And what is the tangent of 30?
30 degrees, right?
Tangent of 30 degrees would be square root of 3 over 3. Okay? So that's just applying that identity. We don't know the tangent of 15. That's not an angle that we recognize off the unit circle. And that's what we can get by using the double angle identities, is we can turn it into an angle that I know off of the unit circle. All right, questions on applying that?
That was it?
That was it. That's why they seem easier when after having to verify identities, this seems really easy, doesn't it? Mundane almost.
So all we really messed with was just the top part?
Not really, we just applied the identity.
Okay.
Okay, here we have the power reducing formulas. So we're taking something that is raised to the second power in this particular case and rewriting it to a power of 1. So sine squared u is equal to 1 minus cosine 2u over 2, and so forth.
Plus. Those two seem easy. Yeah.
Okay, we're going to use one of these formulas to be able to rewrite sine to the 4th x so that it has no power greater than 1. We're going to reduce it to a power of only 1. So this is all going to be algebra. Okay. All right. So that's what we're using. Y'all got all of those written down?
Yes.
Yeah, everybody got them written down? Shake your heads. Everybody shake your heads. Okay. All right. So we're going to take sine to the 4th and we're going to rewrite it in terms of no power greater than 1. So we notice that the power reducing formula for sine says sine squared is that stuff on the right, right? Okay, so I'm going to start out by taking sine to the 4th. And we're going to rewrite that as sine squared x raised to the second power. That's the same thing, right? That's our rules of exponents. A power to a power means you multiply. Now, if I get it into this sine squared x, I can rewrite it using our new identity up here. So this is now going to become 1 minus cosine 2x all over 2 raised to the second power. That's just a substitution. Now we're going to,
But how, oh.
now we're going to see it. Okay, now we're going to square what's in here. Remember our square the first, double the product, square the last jingle that we're learning? All right. So I'm going to square the first term, which would be 1, minus, I'm going to double the product. So 1 times cosine times 2 would be 2 cosine 2x. So minus 2 cosine 2x. And then I'm going to square the last, plus cosine squared 2x.
So how'd you,
And then all of that is over 4.
so where'd you get the plus cosine 2x from if you squared the cosine 2x?
Okay, so if I just have x times x, don't I get x squared?
Yes.
So that's how I get cosine times cosine, which is cosine squared. It just looks funny because it has a double angle in there.
So.
Cosine times cosine is cosine squared,
So
right?
you keep the minus cosine 2x.
Foil this out. On the side, I want you to put 1 minus cosine 2x times 1 minus cosine 2x. And when you foil that out, that's what you get. Square the first, double the product, square the last.
Oh,
That's our special case that we're working on, right?
oh, so you just basically just multiply the numerator and then the denominator is easy, it's just 2 times 2 squared, which is 4.
I squared the numerator and then I squared the denominator.
Denominator.
Yes.
Oh, okay, that makes sense.
Okay, so now we're here, right? We have this. So we no longer have a power to the 4. We have one term in here which has a power of 2. Not quite there yet, okay? So let's rewrite this. As 1/4 minus, I'm gonna pull that fraction out so that I have fractions in front of each of these terms is what I'm doing. Minus 2 over 4 is 1/2. We all agree with that, correct?
Yes, ma'am.
So this becomes 1/2 times cosine of 2x plus 1/4 cosine squared 2x. Right? Okay, so if the only thing in here is this last term that is raised to the second power, we have another identity up here for a cosine to the second power, right? Looks pretty much the same, so it's almost going to be the exact same thing, except we have to make sure we put a plus sign in there. Okay, so we're going to go in and make the same substitution or a similar substitution. So we have 1/4 minus 1/2 cosine of 2x plus 1/4 times, now let's make our substitution here. The substitution says for the double, for the power of cosine squared, right? That's going to be 1 plus cosine times 1 plus cosine 2 times my angle of 2x, just trying to figure out how to say that, divided by 2. Right, the identity says I have 1 plus cosine 2 times the angle. And that angle is the same angle that we had previous. So that's why I kind of surrounded it by parentheses so you could keep up with what I'm doing. Does everybody see that? The angle we're dealing with is 2x. All right, now we simplify from here. Right? Let's simplify from here. So I have 1/4 minus 1/2 cosine 2x plus, and I'm going to leave this 1/4 here and write it as separate fractions. It's easier for me to see. So I have 1/2 plus 1/2 cosine of 4x. All I did was simplify what was inside of the blue set of parentheses right there. And it's easier for me to distribute. So I have 1/4 minus
So where'd you get the cosine 4x?
cosine 2 times
Oh.
2x. So that's all in the angle position. So 2 times 2x is 4x. So I have 1/2 cosine 2x plus 1/8 plus 1/8 cosine 4x. And then we just collect our like terms. 1/4 plus 1/8 is 3/8
How'd you get one? I don't know.
minus 1/2 cosine 2x plus 1/8 cosine 4x.
So where'd you get the 1/8?
Multiply it out, Javi. Look. If I have 1/4 here and I multiply by 1/2, I get 1/8.
Oh, distributed property.
Okay, and that's my answer. Notice I'm done because I have 3 terms here. And each of those terms has no power greater than 1. So I finished. All of it is just using those 2 identities that we just talked about. Okay? Any questions on that? Nope, it's just long, that's all. So we took something that was to the 4th power and rewrote it as a sum of things written in the 1st power. Okay. Anybody have calculus in high school, you'll know that if we have something raised to a power, we have to use the chain rule, and that can get messy. So we want to try to, it's nice when we don't have anything raised to a power, okay? All right. The last set of identities I want you to copy down would be these half angle identities. And you'll notice that when we're talking about the half angle identities, we take the square root of both sine and cosine, okay? And so when you take the square root, you get both plus and minus values. And so whether we use the plus sign or whether we use the minus sign will depend on where that half angle falls. So what quadrant the half angle lies in will determine whether we use the positive square root or the negative square root. Okay, so you want to make sure you write that part down because that gets a little confusing. So wherever the half angle lies, what quadrant the half angle is in is going to depend on whether we're not using the positive or the negative square root. For this one, you'll notice that tangent is the one that has the 2 different variations. I personally like the first tangent, this one here, if I can help it, because I like to have a single number in the denominator. But that's just a personal preference. Now, what this says is that the sine of u over 2 is equal to plus or minus the square root of 1 minus the cosine of angle u over 2. And when we think about this, it's this angle u, it's this whole angle that helps us determine what the sine of the half angle, what the function of the half angle is. That's the way we approach it. Y'all got these written down?
Not yet.
Okay, almost done?
Almost.
All right, we'll come back to it if we need it. I want to use the half angle formula to find the cosine of 105. Now, is 105 an angle that you know off of the unit circle?
No.
Okay, so we're going to use, and I'm specifically telling you that I want to use the half angle formula here, okay? There might be another way for us to do it. Double angle would get us there, right? 210, wouldn't that work for us? We're not doing it. We're going to practice the half angle, okay? So when we're thinking about this half angle, I do know that way that I'm thinking about this, because I'm told I want to use the half angle, I know that the half angle, theta over 2, is equal to 105 degrees. That's what I'm looking at here, okay? And therefore then, theta has to be equal to 210 degrees, right? If I were to multiply both sides of that by 2, I would get 210. And so I can use the cosine, the half angle identity for cosine, which says the cosine of that half angle is equal to plus or minus the square root of 1 plus the cosine of the whole angle theta over 2. That's just me rewriting the formula. And so the way that we look at this then would be, I can now say, okay, well, let's make a direct substitution here. I've got 1 plus the cosine of 210 degrees now divided by 2, don't I? Because theta is equal to 210. So what is the cosine of 210? What's the cosine of 30? Square root of 3 over 2. 210 is in the third quadrant, so this has to be negative, correct? So this would be 1 minus the square root of 3 over 2 in the numerator, divided by 2 in the denominator, all under the square root symbol. And I haven't addressed the positive or negative yet. I'll come back and we'll talk about it in a second. Now notice that I have a compound fraction here. So if I multiply the top and bottom by the fractional part I want to get rid of, so I can multiply the top by 2 and the bottom by 2, giving me 2 times 1 would be 2 and then minus the square root of 3 in the numerator, divided by 4 in the denominator.
So where did you do the times 2 over 2 for, right? Like, how'd you get that?
So I chose 2 over 2 because I want to get rid of this denominator here, this fraction, that 2. And that's how I do it. I'm going to multiply through by the denominator I want to get rid of. So if I multiply the top by 2 and the bottom by 2, that's like multiplying by 1.
Oh, okay.
So now I can take the square root of this technically the only thing that I can take the square root of would be the denominator, right? The numerator looks like this really weird double square root, 2 minus the square root of 3, square root of 2 minus the square root of 3, all over 2. And that's the exact answer. I can't do anything about this, okay? That's as simplified as it can get. It looks weird, I know, but that's the way it gets. Now, let's come back and address, did I need the positive or the negative sign? Go back to our half angle. Where is the half angle located at? What quadrant does this half angle fall in? Second quadrant. Is cosine positive or negative in the second quadrant?
Negative.
So this becomes negative.
Oh.
Okay, that's how we address that. So these look, when we're doing sines and cosines, these are the ones that are gonna look weird like that, with this radical with a radical, square root to square root, okay? Let's try another one. I again want to find the half angle of cosine or cosine of alpha over 2, given that the tangent of alpha, I think that's supposed to say, tangent of alpha is supposed to be 8/15. And I know that alpha, the angle, the full angle, is in the third quadrant, between 180 and 270. So we have a little prep work to do here before we can kind of move on, right? And just to be clear, this should say the tangent of alpha is equal to 8/15, right? That's what that should say. I know where the full angle lies. I'm going to now determine where does the half angle lie. So if I were to divide that angle by 2, I now divide the restrictions by 2, and I find out that the half angle is between 90 and 135. Still in the second quadrant though, right? It still makes it in the second quadrant. Okay.
Man.
Now, if I'm looking for cosine, we know that the cosine of alpha over 2 is equal to the square root of 1 plus the cosine of alpha all over 2. So I need to know, what is the cosine of alpha? Well, if I know what the tangent of alpha is, I can work backwards, can't I? I can use the same things that we've done before. So tangent's defined as y is equal to 8, x would have to be equal to 15, and this is a special triangle. What would it be? What would r be? 17.
Huh?
17.
So did you do Pythagorean theorem?
Yes, you can do Pythagorean's theorem if you don't know this special triangle of 8, 15, 17. Okay, you need to learn that. There's a couple of them you need to learn. 3, 4, 5, you've got down, that's good, right? 5, 12, 13, that's another one. 8, 15, 17, that's another one, all right? It'll make it go faster, but now cosine is defined as 15 over 17. My angle of alpha, right? The cosine of alpha, alpha is in the third quadrant. So cosine has to be negative in that case, right?
Yeah, we're in the second quadrant, right?
The angle alpha is in the third quadrant, so the cosine of alpha has to be negative. Right? Okay. So we're going to come in here, we would say 1 minus now 15/17 all over 2. All under the radical symbol. and simplify this, that would be 2/17 divided by 2, all under the radical, right? If I divide by 2, I multiply by 1/2, so that's gonna make that 2 disappear. This ends up just being 1/17. Or square root of 17/17. This is cosine of alpha over 2. The half angle is in what quadrant? 2, quadrant 2, and cosine is negative in quadrant 2, so this is negative as well.
So either one of those answers would be acceptable?
What answer?
The 1/17 or 17/17, or does it just have to be the 17/17?
Let's rationalize the denominator, which is what I did to get the
Okay.
final answer. Okay? Again, just applying our concept to these. Questions so far? Let's look at one more together then. Especially kind of using that concept there. I've got I want to find sine 2 theta, and I'm told that cotangent theta is equal to 3, and theta lies in the third quadrant. So theta, if theta is in the third quadrant, theta would be what, between 180
And 270.
and 270, that's right.
So,
2 theta, however, is gonna be between 360 and 540 if I multiply those ends, if I multiply those two values by 2.
okay. So can we go ahead and at least, since we know what the tangent would be, can we go ahead and find the rest of them?
All we need is if I'm told cotangent, now I'm gonna use cotangent to figure out what sine 2 theta is.
Yeah.
So sine 2 theta is defined as, y'all tell me, what's sine 2 theta?
Sine 2 theta is, sine 2 theta is a 2 sine theta times cosine theta.
All right, we all agree with that? Yes? 2 sine theta, cosine theta. So I'm gonna use what I know about cotangent theta to identify or be able to learn, to be able to write sine and cosine. So cotangent is x or 3 over r, excuse me, x over y, which is 1. And r then has to be the square root of 9 plus 1, which would be the square root of 10. X squared plus y squared. I'm in the third quadrant. Theta is in the third quadrant. So both sine and cosine are going to be negative, aren't they? Okay, so I have 2 times the sine of theta would be 1 over the square root of 10, negative 1 over the square root of 10. Cosine of theta would be negative 3 over the square root of 10. Now, I'm not going to rationalize this yet because I'm fixing to multiply, okay? And I'm going to hope that when I multiply, I get rid of the denominator, the radical, and I do. When I multiply numerators across, I get positive 6 over the square root of 10 over the square root of 10 times square root of 10 is 10. And 6/10 is equal to 3/5.
So where did you get the -1 over 10?
By the definition of sine, right? So sine is defined as y over r. And cosine is defined as x over r.
Oh, wait. Okay, sorry.
Okay? All right? Any questions on that? You're sure quiet. It's because it's easy. Does it look easy?
It's easier than what's been.
So far, so good.
It's easier than what we've been going over. Oh.
Okay, well, now
I
we have
jinxed
some
it.
identities,
I jinxed it.
okay? So I have the tangent of alpha over 2 is equal to the right-hand side that you see there, secant over secant, cosecant plus cosecant. And I'm gonna solve I'm gonna work on the right-hand side. To do that, I'm gonna go through cosine. I'm gonna change everything in here in terms of sines and cosines. Remember that sometimes makes it really messy at first, but that's all right. So secant alpha can be written as 1 over cosine in the numerator. The denominator, I'm gonna change that again as 1 over cosine times 1 over sine plus 1 over sine. Right? Now, just like before, when we multiplied through to get rid of our denominators, right, of our complex fraction, what would I multiply both top and bottom here to clear this thing of its fractions?
Was it multiplied by the reciprocal?
Nope.
Or would it be the cosine?
What am I gonna multiply by, Lisa? The common denominator? What is our common denominators?
Cosine, sine?
Cosine, sine, right? Common denominators would be cosine and sine. So I'm gonna multiply the numerator by sine alpha cosine alpha.
But what about the plus sign?
Well, let's multiply it out, see what we get. And I'm gonna multiply the denominator by sine alpha cosine alpha.
I mean, would we have to also multiply the sine alpha too along with it? Like
So that's
sine,
what I'm doing. Right?
I mean, like, is that included with the sine alpha, cosine alpha that you're multiplying it with?
I'm gonna multiply the entire denominator that's written in blue by the entire denominator that's written in red. Okay? So in this denominator over here, right, I have 1 cosine, 1 sine multiplied by sine cosine. Notice that the denominator sine cosine disappears, leaving me with a 1 down there.
Oh.
Now I multiply 1 over sine times sine
Oh, so-
cosine, and I get what's left? Cosine, right? So 1 plus cosine alpha in the denominator. And what do I have in the numerator when I make that multiplication? Sine alpha. Okay, so it got messy, but then it got cleared up, right? In one step, one extra step.
Alright.
So look back at your stuff. I'm trying to turn this into tan alpha over 2. Did I do it? Is this sine alpha over 1 plus cosine alpha the half angle for tangent?
Yes.
It is, right?
Yeah.
It's our new identity. And so that's right. So I did it. 2 steps,
It's verified.
okay? So that's how we would multiply through. Again, that's an example of when we would kind of, that's one of those strategies of changing everything into sines and cosines. Okay, all right, let's look at another one.
Question, King,
Yes.
one another dumb question, but so like how exactly did the 1 over sine, the plus 1 over sine x multiplied by that equal cosine? Tangent is equal to sine over cosine.
Where?
Like, how did this times this equal this?
That's the same thing. If I were to say 1 over sine x times sine x cosine x over 1. I noticed this on some of your tests. We can only cancel factors when we multiply. I can't cancel factors between two things that I'm adding. I can only cancel common factors when I'm multiplying,
Oh,
all right?
so
And I'm-
sign's canceled.
So I'm multiplying here the two fractions, and therefore I can cancel their common factors.
Oh,
Okay.
okay, that makes sense.
All right, that's how come we would do that. Here we have the last one, sine theta. Or excuse me, tan theta is equal to sine 2 theta over 1 plus cosine 2 theta. I must have gotten tired of solving everything on the left-hand side. Once again, we're gonna start on the right-hand side. You also want to start with the more difficult side, right?
Yes, ma'am.
We have two new identities. I know that sine 2 theta is equal to what?
Sine 2 theta, isn't that equal to 2 sine theta times the cosine theta?
That's right. So the numerator is 2 sine theta cosine theta. And what is cosine of 2 theta?
Cosine 2 theta, that's
A
cosine.
bunch of different options, right? We have a bunch of different options on that one, don't we?
Which one would equal to these? The one-
Let's use
Or could we do
2 cosine squared theta
-1?
minus 1.
So how can you determine which one will be the easiest one to use?
I believe I've worked this all 3 ways, but I'm gonna stick with just this one,
Okay.
okay? So I have 1 plus. And now I'm gonna substitute 2 cosine squared theta minus 1 in the denominator. Okay, so that's gonna give me 2 sine theta cosine theta in the numerator divided by 2 cosine squared theta in the denominator, right? Because the ones canceled out. Mhm. Now, I have factors, right? Factors and I'm multiplying. So I have 2 is common, it will cancel out. Cosine theta in the numerator cancels with one of the cosines in the denominator, leaving me with
Sine over cosine.
sine over cosine, which is tangent.
Tangent.
When you solve an identity or verify an identity for me on a test, okay, you need to move through most of these steps right here, okay? Don't just finish it with sine theta cosine theta equals tan theta. You need to finish it by saying tan theta now equals tan theta. It also helps if you can do a little less in your head and make sure you can get it on the paper for me, because you know, I'm trying to follow your steps and I want to make sure that your steps are logical, and I can't really reach up into your brain and kind of go through your process unless you have written it on the paper for me. All right, so try to put your steps down as clearly as possible when you're working on that. All right. Now, the last 2 things that we're going to cover, and then it's time for some practice on your own or together. We're going to solve some equations now that we have kind of expanded what we know. The first one we're going to look at here says sine x cosine x is equal to -1/2.
So would we just have to simplify the sine x and cosine x?
How would we do that?
Could we put sine x over cosine x, and then that way tangent would equal 1/2?
But sine x times cosine x is not the same thing as sine x divided by
Oh.
cosine x. All right, well, at least you're thinking of something. What else could we try? This was on your paper. You were staring at it. What would you try?
Oh, could you use the cosine to x identity?
Could we multiply those sides by 2 and then get sine 2 theta?
If I multiplied both sides by 2,
Then you would have 2 sine.
I don't know if you can do that. Let's try it. I know what the answer is. Let's try it. Let me try it. I multiply both sides by 2. That would give me 2 sine x cosine x equal to -1, right? Now what would I do?
Two
The
sine.
left side would be sine 2 theta versus sine.
Okay, so you want to, so what you're wanting to do is take 2 sine x. I want you to keep going with this.
Or the left side would be sine 2x. not
Just a double.
Oh, yeah. Hmm. Equal to -1. Because sine, so what angle when I take the sine of it, am I gonna get -1? Doesn't that occur at 3 pi over 2? And then again, go around again, that would be what? 7 pi over 2, something like that, right? All right. I'm looking at the answers thinking, okay. So we have, hold on a second, let me write this down before I forget. We said 3 pi over 2 and 7 pi over 2, correct? Was equal to 2x. Yes. And then we would divide both sides by 2 or multiply by 1/2. 3 pi over 4, 7 pi over 4. Very good. Yes, that is not the way I solved it, but yes, that worked.
Is that an easier way, do you think?
Sure.
How did you do?
Okay, well, now I'm gonna have to show you my way because you're gonna have a problem on your, I think you have a problem that you're gonna have to use this trick for. I liked that method. Very good. I'm very happy that you didn't at least voice. So if you thought it, it's okay, because I have people in the past who wanted to do this, where they wanted to take the factors that were here and split it up into sine x is equal to 1/2 and cosine x is equal to 1/2, right? Like we did previously. We can only take factors that are equal to 0 and split them up. It's called the 0 factor property, okay? So that's a common mistake that students would make. You know, you all weren't gonna make it, so good for y'all, all right? So this is awesome. Write it down. We multiplied both sides by the same number, so we didn't do anything illegal on the way, right?
So
Made the Javi, just a minute, made the substitution of 2 sine x cosine x is equal to the double angle,
okay,
right?
okay, so you just use the identity, basically.
And I multiplied both sides by 2. That almost looks like I'm squaring both sides, so I hope you don't think that. I multiplied both sides by 2.
Okay.
Then we went on and we solved our double angle identity like we did before. All right. So let me rewrite this. We have sine x cosine x is equal to -1/2. That looks like the double angle identity. But if I want the double angle identity, I can actually rewrite it as 2 sine x cosine x and multiply by 1/2. Well, 1/2 times a 2 negates what I just did, doesn't it? All right. Without ever having to multiply the other side by that 2. Okay, so in other words, I kept this all on the same side.
But
So hold on. So I have sine x cosine x and I wanted 2 sine x cosine x, right? I want 2 sine x cosine x. So if I want 2 sine x cosine x, I can just put it in there as long as I multiply by the reciprocal, because that undoes what I just did on the same side of the equation. It's a little bit
Oh.
different from what we were doing before. Before, what Zoe suggested was we did something to both sides of the equation, and so that was legal, right? That was legit. Here, I'm sticking with one side of the equation, and I am undoing what I did on the same side of the equation. If I multiply by 2, I can also multiply by 1/2, and I didn't do anything, did I? Okay,
so the 1/2 is derives from, because you did the, so you,
it's the reciprocal of the 2,
yes.
yes. So that's one of the tricks. I'm looking at what I wrote right here and I'm wrong. And it would get us back to the same way same area where you were at. Where I got that, I think I do know where I got that. So it's the same substitution, 1/2 times, what, sine 2 theta? 1/2 sine 2x, I should say, is equal to negative 1/2. And we get to the same point, don't we?
Okay, but how did you get the sine 2x? I mean, like, where did the cosine go?
So sine 2x is now, so if I multiply both sides by that, the reciprocal there, if I divide both sides by 1/2, then I would get the -1, which is what we had up there.
But
This is an identity that we just learned. Right? That's our identity we just
Oh, yeah,
learned.
the
That's our
identity.
double angle identity for sine. All right, so you have a problem, I know, on your homework and in these problems where you're basically trying to force something that looks like this into a double angle. And this part over here on the left-hand side, that's kind of one of those mathematical tricks. All right, that's cool. Let's look at this one here. 2 cosine x plus sine 2x. So we can't set this equal to 0. I mean, we can't separate this out into the 2 terms that we have because we don't have factors, right? We have sum, we have an addition sign going on here. So what we want to do is we want to be able to rewrite this in terms of all the same function.
yes, ma'am.
So we're going to rewrite the second term here. 2 cosine x plus, using the double angle for sine, which is 2 sine x cosine x equals 0. Now we have a common factor of cosine x to factor 2 cosine x, we can factor out. 1 plus sine x is equal to 0 when I factor that out. Now I can set each of these factors equal to 0. So 2 cosine x equals 0.
And then 1 plus sine x equals 0.
Yes. So on the left, cosine x is equal to 0, or x is equal to pi over 2 and 3 pi over 2. Here sine x is equal to -1, and so we find x is equal to it's equal to 3 pi over 2 as well. So we have the tools now to be able to take that and rewrite it in all the same form. Also, they're the same angles, right? Angle, single angle, single angle, single angle. Okay, so that we could factor. And the last one that we're going to look at is similar to that one. 1 plus cosine squared x is equal to 2 cosine squared x over 2. So I don't have these trig functions in the same angle, and that's kind of what we're working to get towards here. So on the left-hand side, I'm going to leave that as 1 plus cosine squared x.
But, so if you were to get rid of that square and that 2, wouldn't that be cosine x over 2? And then let's use the identity for that.
No, I don't think so. 1 plus, show me after class.
Okay.
1 plus cosine squared x is equal to 2 times, what is the half angle identity for cosine? It is the square root of 1 plus cosine x over 2,
That's what I was saying.
and then we're gonna square it, okay?
That's what I was saying, Professor.
Okay, well, now we wrote it. Now I'm gonna square it, right? So I have 1 plus cosine squared x is equal to 2 times, when I square that that's in parentheses, I get 1 plus cosine x over 2. Still working on simplifying here. I would have 1 plus cosine x is equal to 2 plus 2 cosine x over 2, which I could cancel.
2.
So I would have 1 plus cosine squared x would be equal to 1 plus cosine x. So all the functions are now in a single angle that's exactly the same. I have one of them that's squared, I've got one of them that's not. But let's collect the variables to the right. So I'm going to subtract this, and I would have cosine squared x minus cosine x is equal to, if I subtract the numbers to the right, 0. So I put all the variables to the left, all the numbers to the right, and now I can factor a cosine x minus 1, cosine times cosine x minus 1. So I have factors that are set equal to 0. I can set each of those factors now equal to 0. And I find for cosine x equals 0, we again have pi over 2, 3 pi over 2. For cosine x equals to positive 1, I have x is equal to 0. So we were just using the half angle identity to be able to rewrite it all in terms of the same angle. Made a substitution, didn't we?
Yes, ma'am.
Okay. Questions on that? We're going to practice some other stuff also. Jimmy, you got a question on this one?
I don't even know what you did.
Okay. When you start working on your own, you can ask a question on that part as well, okay? Okay. All right, so what I have is, we're gonna do a little lightning round of some things here. So on your get your paper out so that you can write it down and hold it up for me. I want to see answers. I want to see them big. All right, the first thing that we're gonna do, is you're gonna see if you can match column A with column B. So these are things that are gonna be utilizing our new identities. So if you wanna have your identities out in front of you, that might be a good idea, all right? So maybe get some scratch paper out.
So we're just gonna
So
basically
you're
match.
gonna match up column 1 with column 2. So on your paper, you're gonna write down really big for me, 1 and then the letter, 2 and then the letter. Okay?
What are we doing? We're just solving these, right? I don't understand what we're doing. Are we solving these or just like? I mean, like, are we solving the equation or just evaluating it?
It has the answer, match the answers to the equation.
I understand that, but like, are we solving for X or with this? Oh, God. Ah.
What one says 2 cosine squares theta minus 1? One of your identities. Cosine 2, not square. Yes, yes. Does this say 2?
Yes.
Okay, I thought you said square. I apologize. Yes. So if I could make a direct substitution. This. This is cosine 2 theta. Wait, you did. Oh, no, you didn't. There. Double wrinkle. this says that we have cosine of 2 times the angle, which is equal to cosine squared of the angle, sine squared of the angle. So this is saying 2 cosine squared of the angle minus 1 fits into that form. This form. And so the angle u is plugged in over here, and we multiply it by 2. And we have the cosine of 2 times. And can you take the cosine of 30 degrees? That's what we're doing. Let me do that. This is the first time you use this, right? And so you have an identity. Find the identity that looks just like that. Now this one, it's 2 cosine squared, some angle minus 1. It has to be exactly in that form. This is not in that form.
No, I did that. I replaced this.
Nope, right. Yeah.
Just double angle.
Same, 2 cosine squared u minus 1. Same thing. And what's your angle? You can look up there. What's the angle?
Oh, so it's
15, right? Or 3 over 2.
oh, yeah.
Yeah, yeah. He is right. No. So the only one that's not- well, first one, that could not be right. Good. For number 2, for number 1. Right, let's look at the first thing. You have. Flip back to your identities. Oh, I see. I just want to change that. And so the angle, right? What's our angle is there? So you plug in the angle here. Which is, so it's now the cosine squared. All 3 of those are variations of the double angle. Yes. No. No. Yes, 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 yes. So far, so good. All right, Javi, what do you have?
C squared.
Yes.
David? Working out, you know, you need to go back to look at it. Yeah, right. Okay, yeah, so we go for 5. Yes, number 5 is hard. Yeah.
Yeah.
The sign of 2 pi over 6. Well, I can find the sign of 2 pi. Simplify it with the 2. Did you figure it out?
Yes.
Okay, so that would be what letter?
Oh.
C? E, yes. No, I would try to do that first, I would go through it and I would see, is there a formula that already looks just like this? Where you have regular n, 1 minus n squared. Make it harder, don't make it that.
That's supposed to be number 3.
Oh, well, then that's right. You get a better feel for just what we're doing here.
It's the other ones. So how do we multiply these two to
No, we're not trying to do that. 2 sine an angle and cosine. Does that fit into our pattern that we have already? The double angle, isn't it? So what this says is I'm going to take 2 sine some angle, cosine some angle. That's the same thing as sine 2 times the angle.
Oh, so just sine 2,
So
sine
it's
2,
just,
sine 2 times square root of 2 over 2, because we have 2 sine.
no, it's this that you're substituting in.
So the sine of square root of
So it's sine 2 times 22.5.
yeah.
Now so now we're gonna follow the order of operations, right? I'm gonna do multiplication, 2 times 22.5, and I get what?
45
So I'm looking at the sine of 45. What's the sine of 45?
square root of 2 over 2.
Yes.
Oh my gosh.
So I skipped it.
Yeah. I don't blame you.
So would you keep the 4 and substitute it in for that?
Can I split the 4?
Yeah.
I can split the 4, couldn't I?
How do you do it?
How would I write it? Or how I was writing that other thinking, right? I can write 2 times 2 sine pi over 3 cosine pi over 3. Now it's this, now it's what we want, right? You still have to hang on to the 2 that's out there. Finish? Your letter?
How do you?
Behind it looks like. What is it? The angle. So what if I separate that times 2
Slash.
Know how to get number 5 now?
I can, he figured out 4. I figured out 5.
We have a TV to show you. So it's gonna
Multiply the angle and 5 by 2. We need that other 2 outside. What 2? This stays here. You're gonna figure this one out. Right? It's fine, it's just kind of- So figure that out.
So that would change all
It's a
that.
number, then multiply. So basically, you're going to part out.
So the only thing, so this.
Okay. I'm gonna put these answers up here. Hopefully you have most of these copied down. And we're gonna practice some more. So 1 would be what, everybody?
C,
What's 2?
E,
E, and 3,
E,
and 4,
A,
and 5, and 6,
E,
D, right? Okay, you can get to 5 by process of elimination, all right? Or you can also recognize that this follows the pattern of the double angle for sine, right? It looks a lot like the double angle of sine. And so I can make it even more by saying 2 times 2 sine pi over 3 cosine pi over 3. Now, that's the double angle for sine, isn't it? And so we make that substitution, 2 times the sine of 2 times pi over 3. The same thing as 2 times the sine of 2 pi over 3. Well, we know what the sine of 2 pi over 3 is, right? Isn't that square root of 3 over 2?
yes, ma'am.
So I have 2 times the square root of 3 over 2. Order of operations, do what's in your parentheses first, right? These cancel, leaving me with the square root of 3, which is f,
That one was hard.
okay? All right, let's look at another set here.
Another piece of paper.
All right. For these 4, you need to determine, what I would do is I would determine, well, you need to determine, am I going to be using the positive square root or the negative square root? What form are these all in? What identity have we done? The half angle identities, right? Right, so this angle here, the sine of 195 in this form has to be the half angle, right? So 195 is the half angle. What did we say about our, we're going to use the positive or the negative based on where the half angle is? So answer those. So you're going to tell me, might be helpful to tell me what quadrant our half angle is in, and then determine whether we're going to use the positive square root or the negative square root is what I'm asking. Jimmy, all I'm asking you, so this is a half angle, right? This is the half angle again. This is the tangent of some angle is equal to plus or minus the square root of blah, blah, blah. This is the pattern. This is the full angle. This is the half angle. All I'm asking in this question is, if this is the half angle, what quadrant does this fall into?
So.
Everybody's looking. Where is 225 at?
Third quadrant.
Third quadrant, okay. So it's the third quadrant that's driving this, all right? And will I use the positive, is tangent positive or negative in the third quadrant?
Negative.
It's positive, so I would use the positive value.
Inside, so, okay, that makes sense. So sine would fall.
So I'm not asking you to do anything except like figure out where the half angle is at. Then tell me if you're gonna use the positive or the negative one based on the tangent or the cosine or the sine of that angle.
Oh, 9 is positive. 58.
So by looking at that angle 225, which is in the third quadrant, the tangent's positive in the third quadrant, we would use the
So we're
positive.
just looking at the first.
All right, I think I got it.
All right, so you're almost done. No. Okay, so let's talk about number 7. Sine of 195. What quadrant is 195 in?
3.
Third quadrant, right? And sine is positive or negative in the third quadrant.
Negative.
So we would use the negative in this case. How about cosine of 58? What quadrant is 58 in?
1.
Cosine is positive or negative?
Positive.
So therefore, we would use the positive one. Very good. Sine of negative 10. Where is negative 10?
Maybe in quadrant 4.
It's in quadrant 4, and sine is positive or negative.
Negative.
So we would use the negative one. Okay? All right. We don't have time to go to the board, so you're just going to work these problems sitting there with the people that are sitting around you. Let me tell you which problems I want you to start tackling, because it's not all of them. So I want you to go through and circle these. We'll see how far we get, and I'll post the solutions to them whenever after class. So you'll have the word solutions if you want. Question 11, 12, 13, 15. You might as well practice some more of that in the middle. Let's do 22, 25. '21, 23, and 26. 29. That'll be all for those. 49, 51, 53, 56, 57, 79, 83, 87. Those are the problems that I have worked from there, all right? Work on those problems. I will always I'll be walking around to help you with the answers if you have a question, or I can give you the answers. These are just additional problems in addition to the ones that you have. Now, understand that you'll have a small Desmos lesson on graphing on what polar coordinates are and graphing polar coordinates. It's a fairly short lesson in Desmos, and then we'll cover the remainder of that lesson in class on tomorrow. All right? So keep working. You have to work. You have 15 minutes left. These are similar to problems that we were working in class.